X-ray production is very important. Knowing what is behind every radiograph that a radiologic technologist take, we will be able to put connections together. It is very important because it is what allows radiologic technologists to do their job. But first, what are X-rays? X-rays is a form of radiation energy which is also identified as electromagnetic energy. With X-ray, it is possible to look through people's body and observe the bones or other pathologies in mind. Understanding the two different types of interaction that create X-ray photons will give us an idea and background knowledge of how the way X-rays are created.
Hello, my name is Heidi. I'm going to be presenting today Brems law and characteristic. Brems law. The main way X-rays are produced is by Brems law. This occurs when the energy is below 70 keV. This is a Brems law atom right here that we have. Brems law interaction only happens when the electron interferes with the force field nucleus. Here we have the nucleus. And an incident electron is the electron that is coming in, is an electron that stops, slows down, or breaks in the nuclear force field. The energy of the X-ray photon. The incoming electron has an energy of 100. The closer to the nucleus, the more the intensity the electron will have. The energy of the X-ray photon is calculated by the difference between the incoming energy and the exiting energy of the electron. Brems law. The field will make the electron to slow down. At this point, the electron will start to lose energy and will also change direction. When the electron stops at the nucleus, the electron will remain with the same entering energy that came in. X-ray photons will be created from the energy lost during the slowdown. To calculate the energy of the X-ray photon in Brems law, what we do is when an electron comes in with 100 energy and exits with 30 energy, that means that we subtract those two numbers from the entering and exiting, and will give us 70 energy X-ray photon. Characteristic. Characteristic interaction. We only see this happen when the incoming electron will interact with an electron in the inner shell. The incoming electron will make a hole in the inner shell that will make the atom unbalanced. The energy of this X-ray would be, so on the K shell, we have a 69 binding energy. On the L shell, we're going to have 12, and on the M, we're going to have 3. So let's say the energy of this X-ray would be from the K shell 69, and it jumps to shell 12. We subtract those two numbers. An incoming electron is going to knock off an electron from their shell and create a hole. So the electrons that are going to be cascading to the hole that is left behind, the removal of this electron will produce the X-ray photons from the characteristic interaction. 74 is the atomic number for a tungsten atom. This is important because due to its high atomic number, it is able to produce high X-ray photons. Thank you.